Good morning and afternoon, everyone, and thank you for joining us today. I'm Kayla Zafropoulos from Capital Link, and I'm delighted to welcome you to today's webinar, Predictive Port Arrivals, Shipping with Oceana, co-hosted by Capital Link and Global Spatial Technology Solutions, GSTS. As ports and shipping companies continue to navigate growing congestion, tighter schedules, and increasing pressures for efficiency, predictability in vessel arrivals is becoming a critical component of effective port call planning and coordination. Today, we will explore how AI-driven predictive insights are helping address these challenges through GSTS Oceana platform. Our discussion will look at the current state of digital maturity across ports and shipping, the operational limitations of traditional ETA information, and how enhanced arrival awareness can support decision-making across both port and vessel operations. We are pleased to be joined by representatives of GSTS and webinar co-hosts, Director of Supply Chain Solutions, Mr. Andrew Black, Director of Products, Ms. Krista Foster, and guest speakers, the Harbour Master and Director of Marine Operations of Montreal Port Authority, Mr. Jean-François Belzile, and last but not least, Mr. Daniel Jodoin, Head of Innovation from the Laurentian Pilotage Authority. We look forward to a practical and insightful conversation covering both operational impact and the evolving role of AI in port and shipping workflows. Thank you all for being here. To set the stage, let's look at where the industry stands today. Jean-François, I'd like to address this question to you and to Andrew. Let's start with the check-in on the state of the industry. What are we seeing in terms of digital maturity in ports and shipping in facilitating port calls?
Yeah, digital transition is occurring progressively and unevenly. The pace varies significantly from port to port and from country to country, depending on those capacities. The facilitation of port calls involves several actors with different requirements, guided, and the decision makers are guided with priorities when come times to support any digitization transition. And this is the reason why it's not progressing evenly. So the costs that is necessary to invest, or the money that is necessary to invest for the digitization, and the different priorities depending on the trade, the port itself, the location, and so on and so forth, and the financial capacity, obviously.
Yeah, I'll just add on that. I mean, I think you touched on some really important things there. Yes, we are in the midst of a big digital shift, and that's important. The idea 8 years ago when I was working at the Port of Halifax that everything would connect in via API, that would have seemed like a far-fetched idea back then. So you are seeing that digital maturity evolve, but ports are funny. You do have ports who are, in many respects, 15 or more years ahead of some of their peer ports. A lot of that has to do with some combination of spending capacity and operational priorities. So you do get a significant mix. I will say that something I observe of the maritime sector in general is that inertia is a powerful force. Those organizations who are digitally inclined, are accelerating so at speed. Those who are less interested tend to be staying put, often because they don't necessarily feel that they have the operational complexity that justifies a massive digital investment.
Very interesting.
I would add, if I may, Andrew, that and you mentioned the APIs, and yeah, that's a nice evolution in the digitization process, the overall process, and it kind of resolves some challenges that we have with interoperability and the complexity of integration of the different systems, and this is progressing positively as standardization of data format and systems is taking place. But yet, as you mentioned, API is a great development in technology supporting the integration and the development of digitization.
And building on that, Jean-François, how does this digital maturity positively impact port operations? And then you, Andrew, too.
Excuse me, I'm a bit confused here. I'm just trying to reset my. Okay, sorry. You don't have to edit that one. With digital maturity comes enhanced sport performance. It supports predictivity, also, which are key factors being that make port attractive to ship operators and shippers. Um, the predictability and the increased performance also allow uh, generating fuel savings for ship operators and ships, which in return improve their carbon footprint. And also, it reduces the delays to ships and terminals, reducing downtime and productivity. We just have to think of um, the possibility for a terminal to short call labor if the ship's ETA was wrong or would be wrong, and reversely, overcalling is also an issue for terminals, which is incurring extra costs for no use. So all this predictability, that's how it comes into play in the port. Yeah.
Yeah, I think that's really bang on. I think the other thing I'll just note about ports is they are one player in an ecosystem, and that actually most of the interesting operational data is not theirs, and so you're somewhat reliant on some combination of data from other parties, from your other maritime stakeholders, and third party data sources, but are really digitally mature ecosystem has that ability to exchange information. You go back to the API example. It means that you have the ability to connect into the TOS of your terminal and the shipping systems and in some cases the labor entities and things like that. That kind of interconnectivity and that interoperability is really creates a strategic advantage that for ports that look to optimize.
That's great. Thank you.
Sorry, Kayla. I was going to say I would agree with that. All the feedback that I'm receiving in the industry shows that predictability is definitely connective tissue between ship and shore. When uncertainty is removed, of course, from both arrival and departure times, then operation shifts from more reactive crisis management to a proactive synchronized execution. So you're better able to streamline ship to shore operations. With synchronized scheduling, if I pick on the port versus a shipping company, for example, if they know exactly when a vessel will arrive, they can optimize labor. So they can ensure that gangs and pilots are ready at the exact moment the ship arrives or is ready to depart. They're also able to minimize buffer time, so reducing that dead time between one ship leaving a berth and the next one arriving. And of course, last but not least, it enables just-in-time arrivals. It is very hard for vessels to adjust their speed or feel confident in adjusting their speed to match guaranteed berthing time window if there's no sense of predictability or reliability in the scheduling.
Thank you, Krista. Yeah, that's great. The value prediction and predictability, which sits at the core of today's discussion. And I would like to shift to Daniel. Daniel, can you please describe the importance of predictability for pilotages in dispatching?
Well, it's quite critical. As you can imagine, there's a lot of moving parts when it comes to ship's pilotage. On top of assigning the right pilots with the right qualification for the incoming vessel, the authority has to mobilize a pilot boat and its crew to take the pilot up to the ship or the case may be bring him back to shore. And also road transportation is very often arranged so the pilot can reach a remote port or remote area. So having reliable predictability allow the LPA to anticipate the effect on transit and synchronize our action to maintain the efficiency of pilotage services. And moreover, during low water or other critical situation like we experienced last summer, that predictability or having some information way in advance allow us to better coordinate all the everybody involved in the command chain, so we can make the proper decision and allow the ship to go up the river.
Yeah, I was thinking, Daniel, you kind of touched on it there, you know, not only from the sea perspective, but also the benefits extending, you know, into the land side and creating a pull effect that stabilizes the entire maritime ecosystem on not just, you know, the shipping company or the ports or the pilotage, but even, you know, downstream service providers. So ship to shore operations are predictable. It allows container discharge schedules to become more reliable. So then you're allowing trucking companies and rail operators as well to coordinate pickups more accurately. So it's not just, you know, the pilots and the gangs and things. It goes more inland than that. Even yard management. So terminals can pre-stage containers in the yard based on confirmed arrival and departure sequences. And I mean, if we go even one step further to the BCOs, and customers knowing when a ship will dock allows them to align their inland water houses and labor. And of course, none of that's possible without the pilot getting on board and debarking, you know, at the appropriate times.
Correct.
Thank you, Krista. Yeah, you brought me to my next question, which is what value does predictive port arrivals bring to port operations and streamlining ship-to-shore operations? And if we could get Jean-François' perspective on this.
Well, the predictability really adds intelligence to the port operations and the coordination that we can bring into the supply chain. So we talk a lot about pilots, ships, stevedores, terminals, and warehouses and whatnot, but the overall supply chain indeed is supported by the predictability, and it's welcome in all fields. Just think of trucking, adjusting the resources, the trucks themselves, ensuring they're well located and ready to go to destination with the well-rest driver. Similarly, for train operators, ensuring that the balance of available rail cars is well set to support import and export. It's can only be improved with predictability, and it starts with the ships and the predictability of their arrival in port and the management of their operations in port.
Yeah, and I might just say that it's the maritime environment is obviously a very dynamic environment, and ETA prediction allows you to better adapt in a dynamic environment where the plans of 3 days ago are often need to be adjusted and adapted quickly based on changing conditions. And so the prediction really helps. And then through one of the capabilities that we offer often in conjunction with that ETA prediction, our intelligent geofences, you get that alert notification that's automated as a means of keeping those interested parties aware of where things are happening at various checkpoints. So some combination of prediction and just visibility and transparency into the ecosystem, and the ability to understand what's happening where and when.
Very interesting to see the benefit, how the extent to the landside operations. I would like to shift gears to see how we can apply this concept within a practical operational context. Daniel, if I can turn to you, how can Pilotage leverage OCIANA to improve operations and navigation?
That's a fairly good question, and we do have a concrete example of what we're going to do with OCIANA. So, moving along with the development of OCIANA with the Port of Montreal and GSTS, we are still identifying areas where the tool could support and improve our daily operation. As an example, the LPA is working in collaboration with GSTS to implement a traffic forecasting tool specifically for the use at Lises Coumé Pilot Station, which is the first pilot station when vessels enters the river system. The use of features such as geofencing will enable better traffic anticipation and thus support more efficient pilot board maintenance planning. And ultimately, this will equip the LPA with additional tools to ensure the resilience and efficiency of the pilotage service on the St. Lawrence. So I'm sure Krista can talk about that geofencing system that we're putting together because we work closely on it.
Yeah, absolutely. Danielle. It's fantastic dashboard that's totally focused on the needs of a pilotage. So leveraging existing capabilities that we have, intelligent geofences and ETA predictions, but taking it from a pilot-centric view. So as Danielle had mentioned, it shows on the screen all of the incoming vessels, regardless of the port that they're going to, that the LPA needs to dispatch. Those vessels are only showing on the screen at the right moment, not too early, not too late. But in addition to showing, all of the checkpoints that they need to cross before they get to the pilot stations, also showing the ETA prediction to each of the checkpoints. So and it's very visual and color coded. So you can see at a quick glance that, oh no, you have, too many vessels coming in at the same time of the same type, and you don't have enough pilots. So just, so in addition to, getting those alerts and notification, it's very visual in nature for, a controller. Just one quick glance is able to see, that they're under resourced or, rarely over resourced. I know that's never your issue. But yeah, no, it's a great tool, and glad to be collaborating with the LPA on this particular tool and dashboard.
And like I've said, that's only the first application we've been looking through, and I'm pretty sure we're going to find a lot more of use from OCIANA going along.
Absolutely.
Well, actually, going forward, we're working on new projects with the GSTS and LPA is also involved in the collaborative platform that we're working on. And I think that's going to be the next stepping stone to improving performance and productivity on the St. Lawrence River.
Thank you. I would like to move on to dive a little bit deeper into the technology of GSTS. We touched on ETA prediction and intelligent geofencing. And I would like to get a little bit more information on another important capability, which is multi-stop planning that Andrew referred to. So GSTS ETA prediction offering includes multi-stop ETA. Could you please tell us a little bit more about how it is leveraged by ports?
Yeah, sure. This is really something that focuses more on ports that deal with containers. In supply chains, one missed port call on a schedule or one late port call can really throw a monkey wrench into advanced plans. And so the multi-stop ETA is used by ports with container lines who have, particularly those who have some amount of short sea shipping involved in their in the voyages that are incoming at their port. To understand multi-stop ETA, you also need to have a model that helps you understand the estimated time of departure, the ETD, and so that is built into OCIANA as one of the capabilities therein. But overall, one of the interesting use cases on this is really being able to have visibility into a string that's calling out your port and to be able to say, yes, overall, it looks like this is on track coming into my port, or no, it looks like this is off track, and the schedule is changing, and therefore we need to make adjust proactively based on the intelligence that's available.
Great, thank you.
And I would add, I would add to Andrew's point that it's quite labor intensive for nowadays to monitor ships multi-stops like he's explaining. And with the support of AI and OCIANA tracking the AIS signal of ships, it makes our life much more easier. Actually, it does things that we would not otherwise have envisaged doing. This is screening information, so much information that it would be too demanding for us to match it with workforce. But we're really pleased with the intelligence that this can possibly offer us.
When people think about multi-stop ETA, they don't realize, I don't think, all the different components, because you're not only thinking about the ETA prediction to a particular port, you have to think about the turnaround time at the ports prior to getting to the port of interest, and how long is it going to take that vessel to turn around at each port, taking into consideration real-time conditions, whether it be traffic, congestion at the port, and whatnot. So you're really combining a port sequence model, an ETA model, and a vessel turnaround model, which of course feeds into what Andrew was talking about in terms of an ETD or predicted ETD in order to get true multi-stop ETA prediction. So it's quite complex, and I think we're quite proud of the capability that we've developed. We all know that oftentimes, even if it's a liner, you can't, always, plan on the vessel taking the exact route or the exact sequence of ports that are in the service. Sometimes, they do blank sailings, they add a port call, they remove a port call. So in addition to being able to leverage known service routes to for ETAs, multi-stop ETAs, we also have path prediction powered by AI. So we're able to predict deviations and then, of course, update our ETA predictions according to not only the known service or port rotation, but also based upon the deviations that now it's going to add additional time, or in some cases, reduce the time in case of a blank sailing to get the ETA to all of the different port calls. And of course, near and dear to Jean-François' heart would be the Port of Montreal, of course. So yeah, absolutely. A very technologically challenging problem and capability.
Thank you, Krista. And you mentioned ETA a lot, and I know it's a very critical, important aspect, but I would like to ask one more question that in a world where agents provide ETA, why does it matter to the port that you have advanced awareness of when a vessel will arrive? Doesn't this information exist already? Jean-François?
Yeah, well, this information provided by agents is relatively reliable, not necessarily arriving timely in the port where it's needed. Also, the OCIANA provides early detection of ships sailing from the port of origin, providing, therefore, an early ETA prediction to the port. So the earliest we get a valuable or a quite accurate ETA, the best it is for the port to ensure coordination is going to be performed ideally. So this is how it sets in, it fits in. Some agents also may miss an update of an ETA. Some companies or ship operators may not be interested in supporting the coordination and providing regular updates with their ETA. Sometimes it's a commercial aspect of things that prevents them from sharing this kind of information. Nonetheless, it's useful to us, and that's a new way of improving coordination and performance.
Yeah, something we hear is, from some of our users is that, it's a means of truth checking the information that's provided, but it's also continuously improving. So, you take the example of if I had Google Maps, it's helping me get to my destination. Am I better off having something that's constantly updating, or having something that provides me updates at various intervals? Obviously, you're going to choose something that's constantly updated, right? Traffic changes, accidents happen, and things like that. Delays happen, and so that ability to get that view of things that are, as the world is changing, is something that we've heard from a number of users is very valuable to them.
Thank you. We touched on geofencing a little bit, but I would like to ask Krista if she can elaborate. GSTS uses the term intelligent geofences. What does this mean? And can you please describe why geofences are smart?
Yeah, absolutely. Well, in the context, I guess, of OCIANA platform, intelligent geofences referring to dynamic virtual boundaries. So going beyond simple geographical shapes, simply by integrating artificial intelligence to predict and analyze vessel behavior. So unlike a traditional geofence, so you just have a static tripwire or line that triggers simple alerts that says, okay, the ship has crossed the line or, entered a geographical bound area or exited geographical bound area. GSTS geofences are a little bit smarter. And again, because they are driven by AI-powered predictive awareness, behavioral intelligence, and contextual adaptability. So if we think about, your typical geofence, it's looking at the current location of a vessel and, oh, yes, it just tripped the wire, so I'm going to send an alert. If you think about an intelligent geofence, it's not only reacting to current location, but it's also using AI to project a vessel's path. So where is the vessel going to next? And then predicting where it's going, but also when it's going to get to strategically pre-configured checkpoints that the ports or the pilotage are interested in. And at the same time, we're not only alerting the pilotage or the port that this ship has crossed a line, and here's the ETA to the pilot boarding station or the port, we're also doing in the background pattern of life and analytics. So we're identifying suspicious movements, and we could also communicate that in an alert. So the vessel appears to be changing course. There seems to be some deviation. So maybe it's not going to stop at the port of Montreal, or it's going to come at a later time. We can also let them know that the vessel seems to be slowing down in high risk or sensitive areas, or some cases speeding up in an environmental protection zone, when triggering a speed restriction alert. And to go one step further, we know that vessels turn off their AIS transponders and they're not supposed to. So our intelligent geofence are smart enough to monitor those vessels that have actually turned off their AIS transponder by cross-referencing it with satellite imagery. So not only are we still able to say that the vessel has crossed a line, or it's going to show up at the port at a specific time, or it's going faster or slower than it should be, we're able to detect hidden threats with regards to risk and compliance that your traditional geofences would simply miss.
We have touched on the value of ETA prediction for ports, a very comprehensive manner. I would like if you could please build on that, Krista. The capabilities and people we have discussed today take a port-centric view, but many of our viewers are with shipping companies. Can you please elaborate on how can ETA prediction support the needs of ships?
Okay. Yeah, absolutely. If you think about a port, right, they're interested in the vessels that are coming to their port and when they're going to arrive. Think of the pilotage, they want to know when vessels are going to arrive at a pilot boarding station or be ready to, depart from a port, but they're concerned with multiple ports. From a shipping company, you're using the same capability, ETA predictions, and in some cases, intelligent geofences, but they're only interested in their fleet and all of the different ports that their fleet is going to and when they're going to arrive. So all of that to say, it is equally transformative for the shipping company as it is for the port or the pilotage. In all cases, it's shifting operations from reactive to proactive. So for a carrier, a precise ETA isn't just a timestamp. It's really a tool for cost control and asset optimization. So if a vessel knows via predictive ETA that its berth won't be ready for 12 hours because the ETD of a previous vessel has changed, which in turn impacts their ETA coming in, the captain can reduce speed and arrive just in time. And Jean-François mentioned it in the beginning, this significantly lowers fuel consumption in addition to GHG emissions. So ETA predictions is allowing the industry to move away from traditional sail fast and wait at anchor. And of course, in doing so, it is allowing shipping companies to better coordinate downstream activities such as bunkering and crew changes. So they are reducing expensive idle time for service providers in addition to the reduction of the cost of fuel that they're seeing by hopefully enabling just-in-time arrivals through ETA predictions.
Thank you. Before we wrap up, I would like us to take a look ahead. If I could get everybody's perspective on this, how do you see predictive port arrivals improving the port call process? And what technology changes do you foresee? Maybe we can start with you, Daniel.
I would say any kind of improvement we can make in having more information about ships coming in and planning of vessels in advance, that only improve and increase the capacity of the whole supply chain of the St. Lawrence River. It's been proven by time with larger vessels coming in, more attention must be put into scheduling the vessel going up, playing with the tides, making sure the vessel goes under bridges and everything. So the more in advance information we can get and carry some calculation with the ship owner to make sure that the vessel will go straight from this Escumane to its final destination, we only can achieve that with more and more planning in advance. So it's going to definitely improve and reduce the downtime, and also maximize the utilizations of pilots.
Well, outside of everything that Daniel just mentioned, which is all right and very thorough, the storage on land, I was going to say ashore. So I'm stuck with this maritime vision of things. Anyway, reducing storage, managing warehouses is also another really positive aspect of what predictability brings into the picture to the overall supply chain. So it's really beneficial to the overall supply chain. I come back to the train management, to the truck management, to the warehouse, to the labor, to the terminals, and ultimately, it impacts the manufacturers and their stock, and the just in time concept is meant to manage the production of plants or goods and ensure that the storage is just fine traveling and stored to destination, but also being produced to ensure that the supply chain keeps on operating well. And that's all linked to predictability.
Andrew?
I might just add, right now what we're hearing from the market is there's a lot of interest in just-in-time arrivals. And so that makes a lot of sense. I mean, it's good financially. It's good from an emissions standpoint. It's good for ports to be able to optimize what they have. It's good for their stakeholders to be able to maximize the utilization of their assets. And so, touched on earlier about this collaborative optimization solution that we are developing with the Port of Montreal and with the Laurentian Pilotage Authority, as well as Canada's Steamship Lines and Clear Seas. It is really about taking that predictability and pairing it with collaboration, so that you can further bridge that gap, that delta between ship and shore, and really just make sure that the information flow is continuous, and that people can make decisions, operational and commercial decisions, a week out of a port arrival, and to be able to say, okay, I'm gonna go across at this speed because I know that I'm going to have services available in 7 or 8 days time at this prescribed time, right? That version of predictability is really the holy grail of being able to make decisions well in advance of getting to your port.
I would agree with Andrew. I'm going to touch a little bit, I guess, on the OCIANA collaborative optimization solution, and go out on a limb here and say that predictive port arrivals driven by OCIANA's collaborative optimization solution will fundamentally transform the port call process from a reactive siloed model into hopefully a proactive, very collaborative, just-in-time system. We've said it a lot on this call, but by accurately predicting arrival times, vessels can adjust their speed, minimizing the need to wait at anchor and reducing fuel consumption by up to 15%, sometimes more per voyage, and lowering emissions. And then if you want to talk about, the efficiency gained by the ports, I mean, numerous studies have been done showing that optimized scheduling cuts vessel turnaround time by more than 30%. We all know that increased efficiency ultimately leads to reduced operational costs. I guess, I think, Kayla, you'd asked about some technology changes that we foresee. I mean, I think the shipping industry is undergoing a profound shift right now, from manual planning to proactive decision making, and that's only made possible by AI-powered predictive insights. And not only ETA prediction, which of course is an AI-powered predictive insight, but also real-time data sharing and collaboration. I mean, you can have all the ETA predictions you want, and yes, that's going to support efficiency and reduce costs for ports, pilots, and shipping companies. But the real benefit comes into the just-in-time arrivals, from my perspective, and real-time data sharing and collaboration is key to that, in addition to ETA predictions. I think GSTS is at the forefront, along with the Port of Montreal, Laurentian Pilotage Authority, CSL, in helping advance the shipping industry with two key technological shifts. The first, as I just mentioned, the shift towards AI-powered predictive insights. So instead of relying on static, often inaccurate self-reported schedules, we're able to provide AI-based ETA predictions, not just for static environments, but of course dynamic environments in real time, and again, allowing the ports and the pilotage to move away from last-minute planning towards long horizon planning. And I guess lastly for me, just want to touch on the shift towards real-time data sharing and collaborative planning to ensure all resources, berths, pilots, tugs, labor, all ready exactly when a vessel arrives. And that is near impossible if you are relying on traditional fragmented email-based communications. You need a shared cloud-based workspace, which is really what the collaborative optimization solution is, where ships, ports, pilotage, customs, other maritime stakeholders can communicate directly in real time through the use of the OCIANA platform. I think that's truly the only way you're going to be able to fully enable just-in-time arrivals, which I believe is, the future of the shipping industry from an efficiency and from a sustainability perspective.
I think it's important to mention, as you said, Krista, that we're shifting from a one-way communication of ETAs to a predictive ETA, and then to two-way communication between the stakeholders and the ship operators or the ship itself. And that's a big evolution, benefiting to the overall supply chain again. So that's the big change, the game changer that the COS is bringing forward, really. Plus, it's building all this intelligence, collecting data, and eventually allowing to manage all this big data and further improve the productivity and the performance of ports and the supply chain. Yeah.
Yeah, that's a good point about the machine learning aspect of the AI-powered models. It is learning from historical behaviors and pattern of life analysis. So it's always improving, not just a static ETA prediction, if you would.
Yeah, and we're keep on pounding on the predictive ETA, but reversely, the terminal operator being running short of labor can advise the ship operator that there's going to be some delay, so they can take action on it. Then the same thing with the pilotage. If they ever have to close a pilot station, they can give an early notice to all the industry, not only to the shipmaster coming to the station. And then things are, although, so we're going to be doing away with lots of phone calls and emails and possible mistakes or misunderstandings by having a clear, common operational picture.
And with that, I'd like to thank our speakers for a very insightful discussion, and to everyone who joined us today. We explored how predictive port arrival technologies are helping improve coordination, enhance navigation and planning, and support both ship-to-shore and land-side operations. We also heard valuable real-world perspectives on how these solutions are being integrated into daily workflows and the operational benefits they can deliver. Perhaps most importantly, today's discussion highlighted how predictive insights and AI-driven decision support are playing an increasingly important role in shaping the future of port and vessel operations. A special thank you to GSTS, Andrew and Krista, for co-hosting. And of course, Daniel and Jean-François for joining us in this discussion. If you have any follow-up questions or would like to learn more about the solutions discussed today, please feel free to reach out to the speakers and to the Capital Link team. Thank you again for your participation, and we look forward to welcoming you to future webinar events. Thank you.
Thank you.
Thank you, Kayla.